Okay, this is question 10. I think there are about 13 multiple choice questions, so we're going to go through all of them. The first type of multiple choice question is when you get a structure and they ask for the systematic name, which is just another way of saying the IU park name. It's probably easiest to just name it from scratch and then check the answer. So that's what I'm going to do. We start with the suffix, the functional group. This is just an alkane, so it ends with A and E. And then I'm going to look at the longest carbon chain, which has 4 carbon, so that's bute. You do have a branch here, that's a chloro, and you do need to number the longest carbon chain to indicate the position of the branch. So I'm going to start from this side, which is closer to the branch, and that means that the name is 2-chloro butane. And yes, we have 2-chloro butane. It's nice to get the answer. Question 2. Once again, I am going to name this from scratch and then I look at the answer. This is a carboxylic acid, which I think it's always very challenging for people to recognize because people can see the OH and they thought it was an alcohol, but no, it is a carboxylic acid. You have to look at the whole thing. So it's going to end with oic acid. And then I'm going to look at the longest carbon chain. And remember that you always have to consider this carbon as well when you look at the longest carbon chain. So in this case, the longest chain has 4 carbon, which is a bute. Now the branch is a methyl. And if I number my carbon chain, I have to start from the carboxylic acid. Okay, so the branch comes out of carbon 3, so I have 3-methyl butanoic acid. 3-methyl butanoic acid. Part A. There you go. Question 3. How many hydrogen atoms are there in one molecule of 3,3-dimethylhexane? It's really just the easiest to draw the whole thing out and then count. So hex, 1, 2, 3, 4, 5, 6. You have a double bond here. There is a CH3 here and a CH3 here because 3,3-dimethyl. And then you just need to finish with hydrogen. Now, because I am not required to draw a structural formula, I can do this just to save some time. You do want to be extra careful around the double bond though, just to make sure that you don't add an extra hydrogen atom when you shouldn't. And then we have hydrogen. This is not great. Now, if I am to draw this in a question, I probably would fix this, but anyway, I really don't need to in this case, so I'm just gonna count. So 2, 3, 9, 11, 13, 16. There we go. Alright, question 4. Which compound is an isomer of octane? Now, I think the thing not to do in this question is probably to draw the whole thing out if you can, just because it's going to take a while. You know that because you have only learned one type of isomer, it must refer to structural isomer. When you get to year 12, you do learn other form of isomer, and the question will be clearer as in what form of isomer is asked for. But in the year 11, it's only structural isomers. That's the only form you have, which means that it will have, if it is an isomer of octane, it will have the same molecular formula of C8H18. So what I'm going to do is I'm just going to write the molecular formula for all of these, starting from A. So 1, 2, be careful with this, 3, 4, 5, 6, 7, 8. So 8 carbon, 3, and then because you have 3 and then you double that, 6, so that's 14. Because I cannot add, that's 9, and then another 6. Is that even right? Okay. Anyway, that's 18. That looks good though. I think I might draw this out later. So yep, 3, 6, 6, 3. Looks good, but because I'm super paranoid, I always always go through the other options, even though A is the answer. Anyway, I feel like I'm paranoid a lot in multiple choice questions. So 2, 3, 4, 5, 6, 7, 8. Ooh, this is not good. So 6, 7, 9, 10, 11, 13. That's only 16. All right, that's good. Let's go to C. So 1, 6, 7. Well, it's C7, so it's not gonna work. I'm just gonna stop there. 2, 3, 5, 6, 7, 8. And then we have 6, 7, 11, 12, 13, and that's still 16. So answer should be A. Alright, I'm going to draw this out because I'm very interested in what this actually looks like. So if you have to draw it out, you have 1C, because I don't think we've done a lot of practice on reading semi-structural formulas. So 1, 2, 3, 4. Now, it's a good idea to start with the carbon that is not in the bracket. So this is the main chain, if you will. 1, 2, 3, 4. I'm going to put a H3 here. That's the first one. And then this one ends here. So this CH3, 2, has come out of this carbon. And the same must be said for that CH3 too. This is also not very good. You shouldn't do this. You know what? I'm going to change this. This is not great. You definitely don't want something like that if the question asks you to draw, because you really want the bond to be clearly on the two atoms like that. Okay. Yeah, so that looks good. Anyway, moving on. Whoa, let's not worry about that. Question 5. What is the name of this? All right, this is a good chance to practice writing out semi-structural formulas. So once again, I'm gonna do what I've just discussed. I'm gonna start with the main chain, which is the carbon that is not in the brackets. So 1, 2, 3, 4. Now the very last carbon has a OOH. You must recognize that that is a carboxyl group. This is not great either. You know what? I'm going to be very, very strict with myself so that I have a better ground to criticize you later when you don't draw proper carbon bond. Anyway, that's still not great, but anyway. Okay, there's a H3 here. This one has a H. Now, it's actually, sometimes people don't know whether that comes out of this carbon or that carbon, but you need to use the hydrogen in the molecules as a guide. So that carbon has 2 hydrogen, which means that this must be where the CH3 is. So this is a structure. So I'm just going to go ahead and name it. It starts with an oic acid. And all right, longest carbon chain is this. So 4, which is bute. You do have a branch of methyl, and you do need to number the longest chain. So 1, 2, 3, 4. So the name, that's a random place for the arrow, is 3-methyl butanoic acid. 3-methyl butanoic acid. There you go. It's a long question for 1 mark. Question 6 is the medic name for this molecule. Once again, it's a good idea to just go ahead and name it from scratch. Okay, it's an in. Longest chain 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. All right. This is as long as you can have it. That's hex. We have 2 branches. Metal and metal. So it's a dimethyl. That's not nice. That's fine. We can live with that. And step 4, I am going to number my longest carbon chain. So what are we looking at? 2, 3, 4, sorry, dimetal hex 2 in 3, 4 dimetal 2 hexene. Now this is the old notation, but that's fine. 6, 7. Okay, we're looking at this. I think, well, hopefully you get better, but for now, it's probably a good idea to translate that into some sort of structural formula, or at least to show you where the carbon is. Okay, actually I'm just going to draw it here. That's 1. No, I'm not going to draw it there. That's not working out too well. So each of the vertex is a carbon. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6, and then there's an OH at the end. Alright, this one has a CH2 followed by a CH3, and then there's a chlorine here. I'm just going to name it now. It is an alcohol, longest chain, 1, 2, 3, 4, 5, 6, 7. I have a lot of issue with this question. Is this question wrong? This should be the longest chain. 1, 2, 3, 4, 5, 6, 7. Now, this is not good because I don't even see a heft here. Anyway, I'm just going to name it. Now that's a CH3. And then there's that. Okay. Anyway, that's a metal. And this is a chloro. Step 4 is to number the longest chain. 6, 7. So the actual name, if I'm following the steps, should be 3 chloro, 5 metal, hept 1 O, which is not in here. Kind of look like this one. I think this question may say 4 is. I don't even know how it has that. Is there an extra carbon somewhere? Alright, let's create a part E, and that's the answer. Please do not do this in your assessment. It's going to be there in your worksheet, which is, obviously very, very dodgy. I know. This is what happened when I do solutions. Sometimes I pick up a mistake in the question. Don't do this in the sack. Question 8. Which of the following organic compound does not contain only 5 carbon atoms? Alright, so do a combination of drawing it out. I mean, that definitely does not contain 5 carbon atoms, but 3, 4, 5. There's an OH here because it's 3O, and there's a 3 CH3 here, so that has 6 actually. Is that the answer? Okay, I don't know. But because I'm paranoid, I'm gonna go to part B anyway. Pentane, definitely 5 carbon, so it's not B. Pentanoic acid, also 5 carbon. Alright, let's look at D. 1, 2, 3, that's a propanol prop. It's a carboxylic acid, so OOH. 2,2 dimethyl, 2,2 CH3. 2,2. This is carbon number 2. 1, 2, 3, 4, 5. Okay. Answer's A. In the ethene molecule, the total number of bonding electrons. Alright, easy. Just draw it out and it will be fine. Ethene double bond. Bonding electrons. Right, I don't think this is that necessary, but I'm going to do it. This is the electron dot. Anyway, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, go. You pack name, and we'll go back to another one of these. So we're gonna name step 1 is to find the suffix, which I think this is an alkene because of the double bond. Longest carbon chain is an easy one. 6 hex. There's a branch here, and then we're gonna look at numbering the longest carbon chain just to indicate the position of the branch. So I have 3 chloro hex 2 in. 3 chloro hex 2 in. How many alkane isomers have the molecular formula? Alright, alkane isomers mean that all the isomer must contain only single carbon-carbon bond. I think with isomers, I think you want to draw it out, and once you get very good at drawing out skeletal structure, it's a lot faster. But for the sake of clarity, I'm just going to draw this, so everything is hydrogen. That's 1. I tend to start with, when you draw out isomers, I tend to start with the version of 5, and then I will gradually reduce the number of the longest carbon chain. So if 5 is the longest maximum, and then if you have 4, then you need to put another one here. Now you don't actually have another version of 4, because if you put the branch here, that's actually identical to this structure. So it's really only one version with 4 as the longest carbon chain. And I think we can do 1 for 3. It's here and here. And if that's about it. That's everything you can have. So 3 possible alkane isomers. Lowest boiling point. Okay, this is another type of question. This one you need to look at the type of intermolecular forces present. Whenever you see boiling point or melting point or any other physical property, look at intermolecular forces. So intermolecular forces. Okay. Now this one, first of all, as you can clearly see, they all have the same number. Well, this one has 1 CH. This one's slightly longer, but other than that, they have 3 carbons. So it's really only the last group that's going to make a difference. This one has hydrogen bond between the molecules because of the presence of the OH. Of course, they all have dispersion forces. This one has dipole-dipole. This one has hydrogen bond. This one actually will have hydrogen bond and dipole-dipole and dispersion forces. This should have the highest boiling point, which is not the question, I know. But if you need to make a comparison between OH and COOH, then COOH has to have stronger intermolecular forces just because it has more oxygen. And this only has dispersion forces. So the answer should be the lowest boiling point. 13. Which compound is not an isomer of hexane? So we're going to do something very similar to what we did before, is that we're going to just look at the molecular formula, but you do need to know what the molecular formula for hexane is. If you remember the general form of an alkane, that is going to be very handy, which is CnH2n plus 2. So if you have 6 carbon, if n equal to 6, then H has to be 14. Alternatively, you can draw it out. Hopefully you don't need to do that. Alright, I'm going to go through all of them. So A, one of my old chemistry teacher told me that if you have a question, when you have to go through every option, it's a good idea to start with D and then work up because they tend to leave the final answers at C or D. Anyway, I already wrote A, so I'm just going to continue. But we'll see whether she's right. 1, 2, 3, 4, 5, 6. So far, not good. 3, 4, 5, 6, 7. Okay, so A is an isomer. We are looking at something that does not have the molecular formula of CCH14. Okay, B, 1, 2, 3, 4, 5, 6. 3, 4, 5, 6, 7, 8, 9. This is good, but because I'm paranoid, I will continue. Now, I'm not sure whether I've done something wrong here, but this is also not an isomer. 1, 2, 3, 4. Okay, 5, 6. So maybe there's two possible answers. 1, 2, 3, 4, 5, 6. Oh, I counted that wrong. Okay, I'm going to check B again. Alright, it's either B or C. Well, we have to live with that. And we have another one. I feel like this is identical to the other one. Actually, no, that's the end because I moved that question up. Finished.